Okay, guys, I think we can start today's session. So, last class, we have been discussing about the simulation. Okay, we have been using the classic gazebo and ROS 2 for the simulation. I think it's very similar to the ROS 1 simulation that we have done already. So we have seen the simulation of Turtleboard 3 and also a differential drive robot we have seen, and we can see the simulation of robotic arm in the upcoming sessions, okay, upcoming chapters. So today I'm planning to go with a fresh topic, which is ROS to perception. Okay, ROS to perception. The same chapter was there with ROS 1. I hope you remember working with ROS and OpenCV, then PCL, all this stuff. Okay. So this chapter is again the same concepts of the things that we have discussed in ROS 1, but there are some differences. Okay. So in this chapter, I'm planning to discuss about the perception. What is robot perception, or what are the things that we can do with ROS, and what are the libraries available to work on perception. Okay. Then we will be seeing some examples like ROS 2 and object detection. You heard about the YOLO, right? So we can see the ROS 2 and object detection example. And also I will be showing how to do 3D object detection using ROS 2. So these are the plans that we are going to discuss in this session. So starting with the perception, I hope you remember something about what is perception, right? We already discussed that in ROS 1. So the perception is basically like the robot will have a set of sensors, and some sensors can perceive the world like through vision basically. So the main example is the 2D camera. You can say like a webcam is a 2D perception sensor, and you can say a lidar or the depth sensor, depth camera is again a perception sensor. Okay, so you already seen the depth camera, all these things. So these all are using to perceive the world. Okay, the robot doesn't have any eyes, that you already know. So instead of eyes, we are putting cameras. So there are different kinds of cameras, 2D and 3D. Okay, so basically it's perceiving the world environment around it. So what is the purpose of this perception? I mean, if you compare with humans, what are we doing with our eyes? Using our eyes, we can see the 3D view of the environment, and also we can do multiple stuff, like we can manipulate objects, we can pick place object, and then we can avoid obstacles. Then there are many things that we can do with it. So similar to that, a robot can also do all this stuff using the perception sensors. Okay. When we come to the perception, I think I just want to uh, start. I just want to start with the ROS perception stack that we have seen in ROS 1. Um, one second. So ROS actually providing us with a set of packages. Okay, for 2D and 3D perception. So this is the repository. This is the main repository that you can find from the Git. So you can find a lot of packages. So for 2D perception, 2D object detection, color detection, all this stuff, we have the Vision OpenCV package. It's not a single package, it is having a set of packages. And for 3D, we have Perception PCL, which is actually an interface to the PCL library. Okay, and if you take the Vision OpenCV, we can see some subset packages like CV Bridge, which is an interface between ROS and OpenCV. And you can also see the image geometry that is for like dealing with image and pixel geometry. Okay, so these are the sub packages that is in the Vision OpenCV, and in the Perception PCL repository, we have PCL ROS, Perception PCL, PCL conversion, all these things. Like the PCL ROS is acting as the bridge between ROS messages and the PCL library. Okay, you know the point cloud we can send through ROS messages, right? ROS point cloud messages. So that can be converted to PCL objects, and also the PCL object can be converted to ROS messages. So that is the main purpose of the PCL bridge and the Vision OpenCV. Okay, so these are the main packages, and along with that there are independent packages for, like, for example, if you want to convert the depth image means the image that we are getting from the Kinect or Intel RealSense, we can convert to laser scan. Okay, and there is an image pipeline set of packages which is for various application. Like if you want to publish an image, like a static image to a ROS topic, we can do that, and you can do the camera calibration, then depth image processing, then image view. We can view the images using this tool. So there are some tools and it's mainly tools for image manipulation. For example, like we are getting the raw image, and we can do some processing, like pre-processing using these tools. Okay, if you want to rotate the image, you can use this tool. So this is the image pipeline. Okay, so I'm just sharing it, and you can see this link. It's actually in September 18, but I'm not sure it is. Yeah, so basically this link shows the porting status. It may be updated, but it's saying we can see almost the same packages of ROS 1 in ROS 2. It's mostly porting. Porting means we are converting a package from ROS 1 to ROS 2. Okay, so most of the important packages like the CV bridge is the bridge between OpenCV and ROS. So that is done. So ROS 1 to ROS 2 is done. And Perception PCL, some of the things are done, like the bridge is actually working. I have worked on it. And depth image to laser scan, that is also done. So there are some packages, some important packages that is already ported. So this is what I mentioned to you, like there are still packages porting, and there are we can expect bugs. So these are the things going on the ROS perception side. Okay, even if it is ROS 1 or ROS 2, this is actually happening. Okay, and yeah, so in the ROS 2, if you talk about the ROS 2 perception stack, it's the same packages that we have seen. And one of the add-on package is that the Open 3D interface. Okay, so I'm not sure you have heard about the Open 3D thing. It's nothing but a rival of PCL library. Rival means like it's doing the same thing. Okay, maybe I can share the links of this. Yeah, so I'm sure that you know about the main use of point cloud library, right? Main use of point cloud library. So what is the point cloud library doing? Point cloud library process the point cloud data, right? So but it's somewhat old, but still it's a good one to process our point cloud information. Okay, and there is another library came, it's called Open 3D. it's called a modern library for 3D data processing. Okay, so basically, what we can do is, if we want to work with some extensive 3D stuff, okay, I didn't work much on the Open3D, worked on very basic stuff, but from my understanding, if we want to do some high-end stuff with the point cloud, okay, then I think better to use Open3D because it's a modern library and which will have good optimized APIs. Okay, and they're saying like if you check, um, I think mostly it is compatible. You can write it. I mean, write code using Python and C++, I guess. Yeah, and um, yeah, it is also like GPU accelerated. There are some part of it GPU acceleration. So this is one new thing. I'm not sure it is compatible with ROS 1 as well. But like the point cloud, you can see extensive tutorial. Okay, like the point cloud library, you can see a lot of tutorials and it's actively supported. So that is the best thing. Okay, so this is one new thing that came to ROS 2. I mean, it not only to ROS 2, but like this is a new library which can we can work with Open3D. So I'm just introducing to you, okay, and we can see some example. Okay, I'm not an expert of this, but the reason why I'm included this because it's a new information. Okay, and it is having a lot of tutorials, so you can easily work on it. Okay. So we will be discussing all this. Let me take the syllabus. So today, my plan is to discuss the important stuff, which is ROS 2 and the OpenCV integration, ROS 2 PCL integration, and showing the two examples, which is ROS 2 object detection using YOLO, and ROS 2 3D object detection. So the last two will be I will be giving some materials because we are running on a virtual machine. I'm not sure it is taking too much CPU or not. So I will be sharing the link so you can simply set it up. It's not any difficult stuff. I think we already seen YOLO in ROS 1. So same stuff in ROS 2. We can see the ROS 2 integration with YOLO V8, which is one of the recently published version. Okay, so let's start with ROS 2 and OpenCV. Okay, so maybe what I can do is I can take a slide so that you will get an understanding what is happening. So I'm just taking a slide first and see what we are going to do. Okay. So okay. Hope you can able to see it. Okay, and yeah, this is fine. So I have a node on the left side. You can see I have a node called camera driver node, and I have a node called face detection node. Okay, so these two are ROS node. Okay, and now so camera driver node is a publisher. Face detection node is a subscriber. And what is the output of the face detection node? It is actually publishing. One second. It is publishing the Centroid. centroid of the face. Okay, so basically we have a camera node which is publishing the image, and what is the rows message that we are using? Sensor messages slash message slash image. Okay, so like it's a basic publisher and subscriber, nothing fancy about it, but the thing that you have to note is that we are not sending text or integer, we are sending image. Okay, so we are simply sending the image, which is a rows message, and on the right hand side you have to do a face detection node. You have to implement it. So how we can do that? Like, the camera node is publishing the image, and this node can be subscribed. Okay, you can simply subscribe it, but how to do after subscribing, how to do the face detection? That is a question. So in order to do that, what you have to do is, once we subscribe the image, we have to do the processing, right? 1 second. So we have subscribed the image, okay, which is a rows image message, and after that you have to do face detection. Okay, so face detection, in order to do the face detection, you need OpenCV. That is one of the library that we can do. So in order to work with the OpenCV, you need a data type called CVMAT. Okay, CVMAT is the data type that OpenCV uses in order to represent an image. Okay, so there should be some kind of conversion here in order to convert rows image message to CVMAT. Okay, 1 second. So this is what the conversion look like. Okay, and we have a program called CVBridge. Okay, CVBridge, which is available with rows 1 and rows 2. Okay, so Hari, do you work with rows 2 CVBridge or something, or this is the first time that you are hearing? Hari, you worked with it before? Okay. I think yeah, he's not.
Okay, sir, now.
Okay. Yeah. So in rows 1 we have already seen this thing. So this is what the CVBridge looks like. This is actually an intermediate program. CVBridge is actually an intermediate program, and that is doing the conversion from rows image message to CVMAT, and also vice versa. You can convert CVMAT to rows image. Okay, so if you have this, then you can convert the rows image message to CVMAT, then do the face detection after that. Okay, maybe I can do the connection. Okay, do the face detection, and after that you can find the centroid, or what you can do is you can convert this face detected image to rows message. Okay, so these are the things that we can do with the OpenCV CVBridge. Rows CVBridge. Okay, so first we are going to see an example. So let me take that example. Rows 2 color detection. this is one of the assignment that I have given to my wife. So this is one small example. There are some changes that we have to make. It is actually done before 2 years. So there are some changes. We have done it using Humble, I guess, but there are some changes. Okay, so the objective of this demo is doing the color detection. Okay, so there is a video. I can show it to you. One second. Yeah. So you can see after starting the application, you can take the RQT parameter reconfigure for tuning the HSV value. So HSV value is actually determine like which object has to segment. Okay, so the color detection work like this. The color detection will be checking the range of value that we have given. For example, the HSV, if we are giving lower HSV and higher HSV, the hue, saturation and value. So if we are setting the hue value in a certain range, S value in certain range and V value in a certain range, then it will be looking for objects in that specific range. Okay, so currently what we are doing is we are manually setting some HSV value. We already have some HSV value tuned and we will be loading that HSV value. Okay, so we can do that in real time. So I'm loading HSV value for blue. So you can see like the HSV value is loaded here and then the blue got detected. Okay, and using the RQT, if I am selecting red or something, green, yeah, green, then the green got selected. Similar to that, if I am giving red, 1 second, the red cap got detected. Okay, so it's a very basic thing, but it is useful. Like you can do the segmentation and detection of any color. Okay, so so I just want to show you the demo of it. Unfortunately, what happened was the camera, when I'm working from the VMware, there are some issues. Okay, so the driver is not working fine. Maybe I can show you the issue. If I am just viewing the camera, you can see there are some problem with the image. Okay, so I can still show you what is happening, and then after that I will explain. I will go through the code. Okay. So first, what I have to do is it's actually mentioned in the README. So first, we have to start the USB cam launch file. I think you maybe heard about the USB cam driver, which is already in ROS 1. The purpose of USB cam driver is that it can read the first camera that is plugged into the PC and then it will be published the image. Okay, so it simply read from the camera and publish the image as a ROS topic. So I can start it, and then it's showing like failed to set AV packet to decode. So means there are some issue, but you can still see the topic coming, and the camera also started from my side. You can see camera info, camera 1, camera image row. So image row is the raw image that is coming, and using RQT you can visualize it, by the way. So using visualization, image row. You can see the same image that is coming. So this is the image that is coming. And now what I'm doing is, so this is the raw image, right? And I just want to check the code. So I hope you know what is the code doing, right? The code basically subscribe to this topic and then converting to OpenCV and then doing the color detection. Okay, so the color detection part is the OpenCV part. Okay, we are focusing on the rows part mainly. So if you check the code, you can see this is a C++ code. This you need to know, or you need to understand the concept. Okay, not the lines, I will say. After that you can learn more maybe after the class. But it's basically like we are creating a node. Okay, we are inheriting from the RCL CPP node and the node name called color detection. Okay, and you can see here we are subscribing to let me see. So I will come to this. Yeah, so we are subscribing to this image called image row. Okay, so what I will do is I will be changing this topic name. Okay, so this is what we are doing, like we are subscribing to this image, and whenever an image come, it will be calling a callback, which is here. Okay, which is here, and then we are converting that image to OpenCV equivalent, and then these are the OpenCV APIs to detect the color using segmentation. Okay, so and initially you can see a lot of lines from here. These lines I will explain. I mentioned about the HSV, right? So there is a lower HSV and there is a higher HSV. So if you are providing a range, these are the functions that is or these are the lines of code which is receiving this HSV value. So you can change the HSV value anytime. So whenever you change, this HSV value got updated, and then based on that value, the in real time it will be the segmentation will be changing. Okay, so I will show you a demo, and then we will be discussing again. So what I'm doing is, first I'm just building the package because I made a change. It's a C++ package, and I'm just building it. It will take some time. Okay, it is taking some time anyway. Okay, yeah. Yes, so it's got build, and then what I'm doing is I'm running the detection. Okay, and you can see this is the raw image and this is the the detection image. Okay, detection image means like it will be segmenting it, and then I am starting this thing called dynamic reconfigure, and then you can set the parameters. So just click on the node name image converter, and then I have a set of HSV values. It is in the config. So let me see what are the objects. Okay, I have a blue object here, so I'm trying with the blue. So we have the contour here, and we have the, so you can see I'm showing a blue box. Unfortunately the image is not that good, but the contour image you can see it's showing white. That means it got detected. Okay, and I don't have anything like colored, only the blue one. But if I'm selecting some other color, rose 2 color detection for config green, then even if I'm showing this, I think it's not detecting, I guess. Yeah, it's not detecting good. Okay, so I hope you got an idea about the application. So just want to know, like, if you have any doubt about this application, let me know. I mean the workflow. So we have loaded some HSV value, and based on that HSV value, it actually search for the object, and then and it can able to track. Okay, so let me know if you have any question regarding the application. Do you have any question how the application works? I think it's okay, right? Or if you have any doubts, let me know. Okay, so I hope it is clear to you. Okay, now I will be just go through the code. Okay, so you can see here, maybe we can start from the int main. So we are starting from the node from here, and then this is the node class, and we are simply spinning it. So these are the things called parameters. I don't know you heard about the dynamic parameters. Dynamic parameters in ROS 1 is basically for changing parameters. In ROS 1, what happened was, like, we can set the parameter, but you can change it, but it will not be updating. For example, you have set a parameter, and then you ran a node, then you change the parameter, but the node doesn't know the value is changed or not unless it is constantly reading that parameter. Okay, but the dynamic reconfigure parameters are like kind of callback. For example, if you change the parameter, it will be calling a callback, and you can update it. So in ROS 2, by default, there is an option to create a callback. Okay, it's not, I mean, you can add the callback if you need it. Otherwise, it will be working similar to the ROS 1. Okay, so if you add a callback, then what will happen is, if you change the parameter, for example, in this case we have HSV. Okay, so lower HSV, higher HSV, lower S, higher S, and lower V and higher V. So there are 6 parameters. So whenever we change the parameter, these value get updated. Okay, and these are the lines that is adding as a callback. It is not happening in all the nodes if you check, but it is optional. Okay, so whenever the topic got some images, it will be going to the color detection callback. Sorry, color detection callback, and then inside this function, this is the CV bridge action. Okay, this is where CV bridge is acting. Like, we got the image message. Okay, we get the pointer of the image message. Here we are using the pointer to save the memory. We are getting the pointer, and using the CV bridge API called CV bridge to CV copy, we are creating a pointer of the CV mat. Okay, so CV pointer that we have created, and then in order to work with OpenCV API, you can use CV pointer dot image. Okay, this is a pointer, so we are using the arrow. So this is corresponding to CVMAT. Okay, CVMAT. So we are converting the current image to HSV. Then we are doing the segmentation using the lower HSV, all these value, all the 6 values. And after that, we are applying contours. Contours means like, for example, an object which is having the same color, you will get a group of white points actually after the segmentation. So we can draw some shapes around it, so you can track it after that. Okay, so we are using a fine contours in order to detect the contours, and then we are drawing that on the image. So these all are the OpenCV part. So this is an application of ROS2 OpenCV, ROS2 OpenCV APIs. So I already shared it. There are some changes that you have to do, like instead of demo.launch.py, we need to change to camera.launch.py. Okay, that is a change that we have to do. Okay, and regarding the package and all, like this is the CMake. Okay, so you can, if you want to work with ROS2 and OpenCV in a package, you can use this CMake as a template. Okay, you need the OpenCV and you need the OpenCV modules. Then also during linking, it will be better to mention the modules that we are using from OpenCV and CV Bridge, all this stuff. Okay, so you can use this as a template, and you can also use ChatGPT to do this. ChatGPT works actually. So ROS2 OpenCV sample code. So it will be giving you, it will be also giving you the Python code. 1 second. Yeah. 1 second. Yes. So am I audible, Hari? Can you hear me properly? Okay. So this is an example code that we have seen in Python actually. We have seen in C++. So this is how we can implement it in Python. So basically it's a subscriber. It's a subscriber, and the image callback using CV Bridge we are converting to OpenCV, and then we are doing the processing. So it's a very simple thing. Okay. Yes. So that is the thing. Now we can see the next example using ROS2 and PCL. Okay, I have another example with me. I didn't build it, but let me see. Let me see. There is an example. Okay. Or I can simply Google PCL ROS2 example. Yeah, this is the template I have taken. So maybe what we can do is we can build it, okay, and see how it goes. So, and then I will explain. Okay. So the PCL doesn't have any much changes. I mean, the PCL ROS bridge, same as OpenCV, like it is converting the sensor point cloud message to point cloud object in PCL library, and vice versa. Okay. So what I'm doing is I'm downloading the zip. Okay. And PCL example. start here. So this is example. Okay, home, then rows 2. Fine, PCL example. So I'm building it. Okay, let it build. Okay, let me check the example. What is the example about? Okay, it is subscribing to Point Cloud and doing some conversion and publishing it back. Okay. We can see the demo. So it's basically doing some filtration. Okay. Okay. 1 second. Okay. So what I'm doing is I just built everything. So first I can show you the demo. After that we can go to the explanation of the code. So these code, the PCL example, you can use the template, okay, which is having everything to get started with the PCL. So what I'm doing is I'm just checking rows to run PCL example, node. Okay, subscribes to, publish to. Okay, so it's basically subscribing to a topic, and after some filtration it is publishing. Okay, so what I'm doing is I'm just changing the topic name. Yeah, I'm just changing the topic name. So in the meantime, I need to find some point cloud sources. By the way, I'm just checking if there is any simulation, like yeah, it's actually there, the turtle bot, but I'm not sure whether we will get the point cloud or not. Let me see. Okay, Turtlebot 3 world. First, let me check the simulation. Okay, simulation is working fine. So what I will do is I will change the Turtlebot name. So currently I have set to burger. I will change the waffle because waffle is having a 3D depth sensor. Okay, I'm just run it again, assuming that the simulation of a waffle will come up. Okay, yeah, this waffle is loading. Okay, now yeah, but unfortunately it is also showing the LiDAR, no point cloud. Oh yeah, there is no point cloud. Okay, let me just check if there is any other thing. Because we need some point cloud publisher, we can simply check for rows to 1 second to PCL publisher or point cloud publisher. We can ask to ChatGPT. Yeah, I think this will be fine. This will be fine. This is yeah, creating a point cloud, and yeah, I think this will work. So what we can do is we can use this for now. I'm just saving to home, then publish, then changing the permission. Okay, and I can simply execute using Python for now. Yeah, so seems like it is publishing some sort of PCD. Yeah. So we can visualize the point cloud even in the RViz if it is working well. Let me check. Okay, it's basically sending one point. That is interesting. I can also echo the PCD. Okay, so there is only one point which is publishing, and what I am doing is I'm just changing the input cloud to PCD, so it will be subscribing to that, and output is PCD out. And now I am building it. Okay, PCL example. What is the package name? It is PCL underscore example. Okay. So we have a point cloud publisher which is publishing one point, okay, single point. So let me see if we can increase it somehow so that we can see multiple points. I'm not sure, but yeah, self point is 111. Maybe I can increase to 100, 100 and 100. Let me see that will work or not. Okay. 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 Anyway. Yeah. So you can see it is subscribing and it is saying the number of points in the input point cloud is 1 and the number of points in the PCL out is also 1. So you can see the RQT graph, simply how it is working. We can see it's very simple. It's just a publisher and subscriber. 1 second. Yeah. So we have the PCD publisher node, which is publishing a topic called PCD, which is subscribing by PCL example. Okay, so this is what happening, and maybe I can try to increase the number of points. Parent frame points, self dot points. I have increased it, but it's not working as expected. PCD height 1. Okay, maybe I need to do some sort of editing, I guess. But still the concept is what we need to understand. Okay, print. Why it is showing point dot shape is Okay. Let me just check. Okay, 1.3. Okay, and into 3. So let me check. It's showing point n comma 3 array of xyz points. Um, Let me change one by one. Showing one only. I'm just visualizing RViz2. So you can see PCD and PCD out, both the topic, but I can't able to visualize it. I'm not sure where it is. It's a single point, by the way. Okay. So now we can just check the code. So in the code, basically what you have to understand is that the main stuff is a conversion. Okay, so this is the main part. So what happening is that you can see here we have created a publisher and subscriber. Okay, once we get the point cloud, where it is going to topic callback. So this is the function that is going, which is here. Okay, so this is a callback of the subscriber, and the message pointer is MSG. Okay, and these all are the PCL APIs. Okay, so we have to convert the ROS2 point cloud message to PCL APIs. So that is the goal. And this function, okay, the PCL conversion. So this is what ROS2 gives to us, or ROS gives to us. The PCL conversion API, PCL conversion namespace having a function called toPCL means we are converting ROS2 messages of point cloud to cloud, which is the PCL equivalent, which is this. Okay, so converting the ROS2 message pointer to cloud pointer. Okay, and in order to convert from PCL to ROS message, we can use from PCL. It's very easy. Like, we can include the PCL conversion header file and two functions actually, to PCL and from PCL. Okay, and after that we can publish it. So it's very easy to work with. I actually send the sample package to you. We can easily work on it without any difficulty. Okay, it's very direct. I mean, there is no complexity involved. Just from PCL and to PCL. Okay, so these are the two important things that I just want to mention. And I think we will have 10 more minutes. Yeah, that is enough for discussing this two stuff, which is ROS2 YOLO V8. So I'm just sharing the idea, and there is a package, so you can simply set it up. There is no thing for programming and all, just setting, and you can start the you can start doing the object detection using ROS2. Okay, so there is a good package here, and there is a good tutorial video here. I will be explaining anyway, no need to worry. Okay, so this is one implementation, and this is some more good implementation. So what happening is that the YOLO V8, okay, YOLO V8, it's one of the latest version of YOLO, and it is having the Python APIs. Okay, you can easily detect an object using these 10 lines of code. Okay, so this package is simply nothing but including those YOLO APIs in your ROS 2 Python node. Okay, so you can use the ROS 2 CV bridge to convert to OpenCV, because this will be taking we can actually provide OpenCV data types to this. Okay, so you can see here there are some examples. Yeah, see here, you can use the OpenCV to give the image to the YOLO. So what is YOLO doing? YOLO is reading an image, predicting the objects. Okay, so that is what YOLO doing. And so what this repo or this package does is that it is subscribing to an image from camera or something, converting to OpenCV equivalent, and then feeding to the YOLO APIs. Okay, and then drawing the objects detection, the bounding box and all. Okay, so this is the latest package that you can use. Using this single launch file, you can work on all this stuff, and this will be the output. Like, you can able to see the objects, and also the 3D detection. That is actually interesting, I guess. You can able to you will get the transform, I guess. That I need to double check, but the depth also you will get. So this is one of the output for the YOLO V8. Interesting, right? So the object will be marked, and it will be showing the name of the object and the probability. Okay, so this shows the 3D bounding box as well. That is interesting. It's a 3D segmentation. This is very good. You can see the 3D bounding box of the object detected. Okay, so there are 2D and 3D detection. You can find the exact 3D pose of the object. Okay, I'm not explaining things inside it, because it's very straightforward. Just set the package according to the instruction. The one of the dependencies, the Ultralytics YOLO V8, so that you need to set up, which is a single command. Like, you can simply use pip install Ultralytics, so it will be installing that, and then you can start using this repository. Okay, so nothing complicated. Okay, and there is another thing I just want to show you, which is YOLO 3D. Okay, YOLO 3D, which is like what will I say, again, very similar to the YOLO stuff, but this is exactly fitting a 3D bounding box around the object. Okay, around the object. So that is what another thing, like it can fit the bounding box from this video you can understand. See, you can see a 3D bounding box around the object. Okay, so that is what the YOLO 3D is, and there is a project that so this is the official repository of YOLO 3D. I'm just sharing it, and again it is using Python. Okay, and this guy actually created a script to do the detection using rows. Okay, it's a simple rows to Python node which is doing this. Okay, so these are the two things I just want to add in today's class. So these two things you can test it out. Okay, no need to explain. I think you already know what is the input and output. We already seen this detection in rows 1 as well. Okay. Okay, so now I think we can conclude the session. So if you have any question, let me know. After that, like, we can conclude it. So any question, guys?
One question. In the last example of YOLO,
Yeah.
We are able to see the image in the RVs, right? So do we have a map of that environment, or
This one?
how the coordinate?
This one? Or
No, the previous
okay,
the
okay,
office kind.
okay. 1 second, I will take this one, right?
In this example, exact position is also. Or if I miss the point at any time.
Yeah. So what you can see is this is an image. This is an image, and this is a point cloud. This is a point cloud actually. Okay, so in RVs we are simply seeing the point cloud and image. That's it. So there is no map or something. And 1 second. Yeah, this is yeah, there are some interesting stuff here I didn't shown to you, which is human pose as well. It is showing. Let me, yeah. So RVs is simply showing the image and the point cloud. That's it. And these all are the markers. There is an option to visualize markers. So these things are the markers. Okay, and you can also see it is detecting the skeleton, which is again one of the add-on to this YOLO. So the name, prediction, the probability of that object, then the 3D pose, everything is there. I think it's a part of a robot, I guess. Yeah. Clear, right? Any more question? Okay. Okay. So yes, so that's it from my side. So tomorrow we can see the Open 3D a little, and then I'm planning to discuss about the, may not be micro rows, but maybe with the autonomous robot in rows 2. Maybe we can take some standard examples and we can discuss. And then yeah, so let me see. So tomorrow we can discuss on the Open 3D and rows some examples, and then we can switch to the autonomous food delivery robot. We can discuss the design, how we can do it, all this stuff, and later we can work on the micro rows part. Okay, then thanks for attending. See you next class. Okay, bye everyone.